Alrighty now, here we go. Torque problem, example number 4. Again, everything is in equilibrium. Very important to recognize equilibrium here. So if you were to try to do some of the forces here, which is probably the best thing to do, is to start with a free body diagram. Right? You want to draw the free body diagram. I don't know what my dog is doing in the background over there. There's a force of tension over here. There's this thing's weight down that way. There's the pole's weight, the sign's weight, the pole's weight. Then there's the normal force, and then there's some friction. If you were to try to go some of the forces, which makes sense to do some of the forces in the x direction equals ma, which equals 0. Forces in the x direction, sideways forces, there are only 2. The normal force minus ft cosine 37 degrees equals 0. So you end up with something pretty simple. Normal force equals ft cosine 37. The cosine of 37 is 0.8, so you could say Fn equals 0.8, the force of tension. Well, that may be useful, but not yet, because we don't know anything yet. Then you can go some of the forces in the y. Equals ma sub y, but again, it's not accelerating, so it all equals 0. So the forces in the y, you got the friction force up, the force tension times the sine of 37 degrees, those are up, minus the weight of the pole itself and the weight of the sine. All that equals 0. So you could figure some things out here. You could say the force of friction equals, again, the sine of 37 is 0.6. Force of friction plus 0.6, the force of tension, minus the weight of the pole is going to be about 20 newtons, right? It's 2 kilograms. The sine there is 50 newtons, 5 kilograms. All that equals 0, so you end up with the force of friction plus 0.6, the force of tension equals 70 newtons. And what we end up here is we end up with 2 equations, but 3 unknowns, and we're stuck. We have unknown of Fn, we have an unknown of Ft, and we have an unknown of force of friction. So we end up with 2 equations, but 3 unknowns. Stuck, can't do anything. Some of the forces doesn't work. You know what is going to work? Some of the torques. Okay, some of the torques. Again, very important to pick a pivot point. All right, picking a pivot point is important. I'm going to choose this spot right here as my pivot. I want to call this normal force, force 1. I'll call the force of friction, force 2. I'll call the weight of the pole, force 3. Tension, force 4. And the weight of the sine, force 5. So the sum of the torques equals IA. Again, since it's not accelerating, that's 0. So we're going to get torque from force 1 plus the torque of force 2 plus the torque from force 3 plus the torque of force 4 plus the torque of 5 all equals 0. Remember, torque, the equation for torque is FR sine theta. The force, distance from the pivot, sine of the angle. For one, the torque of one, you're going to get the normal force times R. If I make this point R, normal force, that's going to end up to be 0. And the sine of 0 degrees is 0 sine theta. You're going to end up with the normal force times 0 times 0. That's going to go away to 0. That's very nice. That's torque force 1. Plus 2 would be the force of friction multiplied by R, multiplied by the sine of theta. This time they're acting at 90 degrees to the pole. So that's going to be the force of friction. But again, R is 0 times 1, and that goes to 0. So that vanishes. Plus, here's the third one. The force of gravity of the pole times R. The whole thing was 8 meters, so that's going to be 4 meters away. R times the sine theta. So the weight of that thing, a 2 kilogram pole, is going to have a weight of about 20 newtons times 4 meters times 1. Okay, now also, that is going to cause it to rotate. It's going to try and pull the pole down and make it rotate in this clockwise direction. So that's going to be negative. So we're going to end up with a negative 80 Newton meters. That's going to be the torque from that third force. The fourth force, tension of the rope. Force T times R times the sine theta. Force T, we don't know what the tension is. No idea. R, it's all the way at the end, so it's 8 meters. And theta is 37 times the sine of 37. Sine of 37 degrees is 0.6. 0.6 times 8. Well, 6 times 8 is 48, so it's going to be 4.8. So we're going to get, this is going to be positive 4.8, because this would cause it to rotate counterclockwise. So that's positive. Clockwise, negative. This one here is counterclockwise. So it's going to be 4.8, right, times the force of tension, plus our last force. Again, this one's going to be negative because this would cause it to rotate clockwise. So that'll be negative. So it's really negative. It's going to be the force of gravity of the sine times the radius times the sine. This is acting at 90 degrees. So this is going to have a weight of just about 50 newtons, 5 kilograms. It's at 8 meters away. And that's the sine of 90 is going to be 1. So that's going to be negative, again, because it's going to make it rotate clockwise. So negative 50 times 8 is 400 Newton meters. All of that equals 0. So we get negative 80 Newton meters plus 4.8 of tension minus 400 Newton meters equals 0. Combining like terms, negative 480 Newton meters plus 4.8, the force of tension, equals 0. Bringing that over there, we get 480 Newton meters equals 4.8 times the force of tension, which leaves us the force of tension to be 100 newtons. Now we figured something out. That's pretty cool. Some of the torques works, gives us a way to figure out the tension. The tension is 100 newtons. So now we know this is 100 newtons. That was the first thing they wanted you to solve. Tension in the rope. Tension equaled 100 newtons. The next thing they asked you to solve for was the normal force, the force of the wall acting on the pole. Well, if we go back to here, the normal force equals 0.8 times the force of tension. Now we know the force of tension is 0.8 times 100 newtons, 80 newtons. Force normal equals 80 newtons. We got the tension to be 100, and we get the normal force to be 80. Second thing they want you to solve for, or the next thing they wanted you to solve for, was the force of friction, right? Well, force of friction isn't from the y direction. So the force of friction plus 0.6, the force of tension, was equal to 70 newtons. Force of friction, this is 100. 0.6 times 100 newtons equals 70 newtons. So the force of friction plus 60 newtons equals 70 newtons. What plus 60 gives you 70? The force of friction equals 10 newtons. And now the last thing they want to know, they asked you to solve for, was the coefficient of friction. But the force of friction is equal to mu times the normal force. We just figured all the stuff out. 10 newtons equals mu times 80 newtons. So mu is equal to 10 newtons divided by 80 newtons, or 1/8. Mu is equal to 0.125. So we got, there's the 4 answers. Very much like what we did a while back. There's a lot going on here. You can't solve this problem if you didn't pay attention back in the end of September. You're out of luck. Some of the forces splitting up X and Y, equilibrium, acceleration is 0. Some of the forces gives you too many unknowns, so you have to use some of the torques. All right. Take a good look at that, pay attention to it, and be able to repeat it.